Yeah.
Yeah, it goes straight up. Like I'd say like 30, 40 miles. Yeah, it went further east. That's why Macon doesn't get hit too hard. I think Athens going to get hit harder though. Let's see where it's at.
Like a week ago?
Yeah, very
Hindsight 2020.
It's like they overdo it and like
just go with your gut.
Yeah. No, I use the knee when I'm making a fantasy football line.
This was the very first advisor.
Yeah.
Monday.
We already went over here.
Also, how's the dust set? Because when I was looking, it looks like the dust has probably got some heavy rain in some of the more developed. Yeah.
All right, we can get started with Weather Watch on the best day of the year. Unbiased opinion, but it's a very good day today. Starting with a loop of the infrared satellite view of Hurricane Helene. So it developed and became a hurricane right off the coast of the Yucatan, right around this time. Was discombobulated, and then I'll let it show itself. Rapidly intensified from Category 1 to Category 4 as it made landfall in the Big Bend of Florida. It even had an eye into Georgia. So that's how strong this storm was. I bet if it had 3 more hours over the Gulf Coast, we could have easily seen a Category 5 hurricane. The rating doesn't really matter because, as we will see and have seen before, Category 4 storm can destroy lives. And we'll probably be seeing that in the aftermath. But this was such a highly impactful storm. You can see how wide the clouds stretch. It became ingested with a trough that we'll look at later too. So you can see these are cloud features from Helene going all the way up into Canada. That's how impactful this storm was. And where you get a sense from the clouds and the cold cloud tops, I'll let this replay here. Days before this storm was even making landfall, it was producing heavy rain over the southeast. And I'll show you that here. So we can see the circulation forming. This was sitting there for a couple days, just off the coast of Mexico. Trough went through, started raining over the southeast. Then you get enhancement from the outflow of Helene. Some of these places it rained for days, and then Hurricane Helene hit them. So they got 10 inches of rain before the hurricane was even near the places in the southeast, and they've had extreme flooding from that very fact. But gorgeous look on satellite. Unfortunately, a destructive storm though. And I'll let it replay once more.
Yeah, that's a mountainous area too that got the heavy rain.
That's right.
The southeast part of the Appalachians is very high terrain.
That's right.
Lots
It was
of valleys.
bullseye right in North Carolina and Tennessee where the mountains are located. And some of these cloud tops are reaching almost 180 Kelvin, which is very high up in the atmosphere.
That's the cold point tropopause temperature.
Exactly.
Approximately.
And there was lightning around the eye, which I'm not too well versed in hurricanes, but I know lightning is a significant indicator that the storm was very strong, and it was having a ton of lightning as it's making landfall on the coast of Florida. So unfortunate, but a good look at the storm here. This was the 7th landfalling hurricane in 7 years that was Category 4 or higher in the United States. So the Gulf Coast has been slammed with these hurricanes repeatedly, and especially recently here. Here we go, we'll get a sense. So you see it's already raining. Helene's down here. That's how far of an impact it was. Very visible eye, you can see convection. The highest reflectivity is around the eye center. It had an eye based on the radar loop all the way up into southern Georgia. We'll let this play again here. Days of heavy rain. And then you put 50 to 70 mile winds on top of wet soil. Trees are coming down though, very easily, and big trees too. So gorgeous storm.
I guess some of the close-up radar imagery from, I think it was the Tallahassee radar, there were all kinds of little mesovortices, like 5, 6, 7 at a time, all breaking on the northwest side.
I'm sure.
As it was approaching the coast last night. It doesn't really show up as well on this image.
That's right. And this is a look at just what's going on above. Let's look at the video I have here. Because hurricanes also bring storm surge. So they were calling for 20 feet of storm surge. Watch this video. Look at how fast the water's moving from the ocean. 20 feet of this coming at you. This is like a front driveway video. And look at how fast the water's moving. Not sped up. This is every second. And you have the ocean just, invading land. So it'll be interesting to see the satellite go over Florida afterwards and look at how much area is covered in this water, because this is just one look at one place. They had impacts all along the Florida coast from all the storm surge and everything. So, and you can see it's heavy raining too, on top of all this water. So you get double impacts from this.
I think I saw on the Hurricane Center's website today, the first time I've ever seen them talk about it this way, inland flooding receding during the day in Florida, because the winds will be turning around and the water will be going back out. It's just incredible.
It looked like you could sort of see some brown water along the west coast on the visible
Is that
this
right?
morning. Yeah, that's
Wow.
We can take a look at that, yeah. Let's pull up the current visible, please. And I'll start with the North America, and then we can go to the zoomed in CONUS one. Yeah, so you can imagine 20 feet of water coming in, taking boats, houses with it, and then it all receding and taking everything out into the ocean. This is a look at what is left of Helene. It's still a tropical system. You can see now it's a very wide cloud field compared to what it was earlier. That's because it has been adjusted with a trough, which I will show here. It sort of looks like there's some smoke as this storm, moved from the Caribbean up into the southeast. There have been many fires down into South America, and this appears to be some smoke that it ingested as it was moving northward.
Wow.
I couldn't really confirm that with the RGB. It was unclear what exactly this was, but it looks like smoke from the visible at least. Definitely cirrus level as it's wispier. Here's another hurricane. So this is a hurricane right here. This is Hurricane Isaac. This is a tropical storm. Much different size, much different impacts. This is impacting the ocean, obviously. This is impacting land, but this is a stronger system at the current moment. You would not be able to tell that from if you had no other information. And then there was a hurricane, Hurricane John made landfall in Mexico. Some of that moisture was being driven up into Helene as it made landfall. And so we'll have to look at the rainfall totals, but I'm sure you can see the 20 inches plus of rain from the system as it made landfall and is continuing to impact the southeast and then even our region. We're getting some of the cirrus clouds from Helene right now. And then places where the hurricane hit yesterday, completely clear now. So you'd have no idea if you were to just look here. Could we zoom in and see if we can see some of the features as it made landfall? Let's see. So it's not very obvious, current impacts just from this satellite look, but I'm sure we'll be seeing pictures and images from Florida as we go forward here. You can see it's still convectively active. We can see cloud tops. As the sun angles high, you can see the different bubbles are higher than the other cloud decks. Drawing a lot of moisture. See a lot of this cumulus flow right off the Gulf. We'll look at surface map. There's high dew points, so still potential for heavy rain with this, even though it's just a tropical system at this point across the southeast here.
We do have a full res of Florida, but not in color.
Okay, that's fine. Could we actually pull up the week-long infrared loop too? Sure, please. We'll look at. So we have Helene, we have a trough over us. That's about it. But we'll look at how we got there from this week-long look. So this starts last weekend, and I'll point out once it restarts. But we can look at just the loop first. We had trough associated rising motion and clouds of precipitation move through. You can see it as it slowly tracks towards the southeast. Here's Helene developing. Here's Hurricane John. We'll eventually have Hurricane Isaac. You can see the cloudiness and the cloud field extend well up into Canada, southern Canada, Ontario, up to the current point. Right at the start of this loop, this was last week's 4 inches of rain, 4th wettest day in Madison history. Doesn't even compare to the time window that we're seeing from Hurricane Helene. It was just 12 so hours of very intense rain, but 4 inches of rain at the start of this loop for us. Here's Hurricane Helene, all the moisture and associated everything. And so we'll take a look at the trough that moved through also and produced our rain, and then also produced the current satellite loop that we're looking at here. Can we go to the climate data page?
Yeah, Steve Vavris had updated them today, and Steve mentioned that he said Madison's precip for the year to date is on pace with the wettest year on record.
Oh, wow, okay.
Which is kind of astonishing.
That's 1881, I think, isn't it, or something like that? It's really a long time ago.
Perfect. That leads very nicely into the climate data page. So first, if we could go to the precip, since we were talking about that. Yeah.
Whoa, look at that.
Here we are. We're almost off the chart. How high the precip has been. The blue line is the average to date. Here's where we currently are. 48, more than 46 inches of rain. Normally we see 38, 37, so about 10 inches more than normal. And if we get any more precipitation, we'll continue to go higher than normal, obviously. What's creeping down here? Snowfall. So we have the snowfall maps now. We'll have to keep track of that. First snowfall not for a while, but I noticed that has made its appearance again. And then if we could go to the temperatures, you'll see we had a string of days, very high temperatures. Red is normal. These are like 10, 15 degrees above normal for a week plus. We had our little cool down with the rain, and now we're back to above normal. Close to 80 as of recent, which is just too warm. I would like it to be fall.
And embedded within that is a streak of 12 straight days in the month of September that's never happened before. We're
Really?
over 80 degrees. Yep,
Yeah, right around here.
right in there. It ended on Saturday, but we got it on Saturday. We got the rain
And
on Saturday.
Current forecasts have us getting close to 80 again. So if you like summer, you're welcome. If you don't, sorry. Could we go to the 500 map, the loops, please? We'll get a sense of why we've seen such warm temperatures from the loop of 500 maps here, and then the current, what's going on currently as well. And we'll start on Monday, if I could, at 500. And 0Z is perfect. So looking at this picture here, this was Monday. We had a trough feature moving over the southeast, not well defined, but it's definitely there. Centered somewhere around Nebraska. Then there's something creeping over in the lee of the Rockies in British Columbia, which we'll note as we go forward here. But just from this look, Monday was rather boring. Look, if we go 2 clicks forward, so a day, you're good. You'll see almost out of nowhere, we have the development of a trough in the lee side of the Rockies. And then this trough becomes more pronounced over the middle part of the country. Not really moving though. Let's go another click. We can see the two become, start to interact. They definitely become more pronounced. We have a sharper curvature max with the trough to the north, and then even one to the south here. One more click. Hurricane Helene is somewhere down here. Off the coast of the Yucatan. Now we have, look at this trough. Very pronounced across much of the CONUS and then into central Canada. Not a lot of airclinicity, but some associated with it. If we keep going here, here's Hurricane Helene forming. We have our now pretty pronounced trough slowly moving over the central and eastern part of the United States, still connected all the way into Canada. I'm not even going to touch on this, but this was another interesting development. If we keep going, we'll see this trough doesn't really move. Situated over Illinois, Missouri. Here's Helene, if we keep going. Now we're into Wednesday evening. We have a cutoff trough, 2 geopotential lines. So this has not moved, at all from a couple days now. Hurricane Helene beginning to move up towards the Gulf Coast. One more click. Now we see the interaction begin to form. The outflow from Hurricane Helene was definitely being driven just straight north. We can see northerly flow all the way from Florida up into Pennsylvania and the northeast. This trough still has stayed relatively the same geospatial location. It's kind of becoming divorced from the wave train that it once was associated with. Let's go one more click. Now this is yesterday evening. These two become oriented very close to one another. we'll begin to see them rotate around each other. Hurricane Helene is becoming ingested into the trough feature, which I had been talking about. One more click will get us to this morning. Where did Helene go? Let's go back one click. Definitely obvious geopotential minimum. One more click forward. It's gone. It's almost completely, we do have a minimum geopotential, but that was from the pre-existing trough. So they're definitely interacting. It's unclear where, if Helene, moved all the way towards the southeast, towards Mississippi and Alabama. Is this the remnants of Helene this morning? It's unclear to tell from this look which one's Helene, which one's the pre-existing trough, but we have gigantic, just lower geopotential height, and this is all our cloudiness that we are seeing over the southeast this morning. This whole loop that I've been showing, if we could go back, just back to Monday, please. And we'll focus on Desert Southwest. You could just slowly click forward if you could, please. We'll see a ridge begin to develop over the southeast. How many times have we seen this year? Too many. If we keep going, we'll just see this ridginess sit over the western part of the United States. Phoenix now is setting more records for hot weather. Now they've had the latest day of 110 plus calendar year, nearing their most 100-degree days ever. So, it's still warm. We've had consistent hurricanes and tropical systems develop over the southeast. It's been wet and rainy and relatively cooler. In consequence, over the west, it's been very dry and hot. So that's something to watch as well. And then, could we go to the surface now, please? And so we'll look at a surface look at what's going on with Helene. We could go over the southeast, perfect. We can see, here's the center of circulation, about 880 or 984 is what I see for the lowest pressure. Dew points are very high on the eastern portion of Helene, 78, 81 on the coast of the Carolinas. Heavy rain, you can notice, moderate rain being reported everywhere. There's heavy rain in Missouri from this. These two stations right there. And then over where it was devastated by Helene, clear. So, interesting.
Oh, while you're here, there's that wave of where the weather stations are gone in Georgia.
Oh, right around here?
Yeah, and in Florida too.
Yeah, that's right. Yeah, so I'm sure stations are, maybe some of these are underwater or people just evacuated, but that's right. Void of where Helene went. Have it up. We have a pretty good day, 73 over 58, although not climatological. It is a nice day for us. And then, let's see. And then can we go to weather.gov, and that'll be my last page I show. And so with Helene, as we can expect, high impacts for the southeast. We have flash flood watches and warnings, tornado watches. These are all wind, this like grayish brown color. Wind advisories and wind warnings. So it's still highly impactful for these states as it's raining out. The other feature, excessive heat warnings, where we saw that ridginess over the southwest, which does not need more heat. So something to watch as well. And then it even looks like heat advisories in Florida on the backside of the system there. So anything anybody wants to see or questions? Yeah.
Yeah, earlier you were talking about how that low pressure and Helene kind of combined.
Mm-hmm.
Would you see pretty similar conditions, I guess, throughout the extent of the storm at this point, minus some areas being a bit stronger, some areas being a bit weaker, or would it be more like mid-latitude thunderstorm system and then a tropical-like systems, depending on where each side is?
Could we go to the infrared loop, the current infrared loop? It's a good question. Or maybe the week-long one would work too, if we just pull up and then go towards the end once it loads here. It sort of looks like from this look, We have, more stratiform precipitation on the western side. This might be from the trough feature. This also might be just, the pre-existing precip out ahead of Helene. But if we keep going here, you'll watch the center of Helene moves up and kind of stays on the eastern side of the trough. Here's where you have more deeper convection based on the IR loop versus, more stratiform. This still might be convective, but the highest cloud tops are on the eastern side. So it looks like most of the tropical features of the storm, we saw it in the dew points, especially over the Carolinas, are just to the east of Helene, and then this might be where you see more of the just trough that was sitting over there. Lighter precip, but still impactful. Even all the, let me orient myself, all of the wind warnings were more towards the north side and the eastern portion, so I think that's more associated with the tropical nature of Helene. You see that? Yeah, just tracking the color. The deepest colors are on the eastern portion. But it is becoming messy and merged, and so good question. Anything else? All right, perfect.
All right, thanks, Patrick. And you should know it's Patrick's birthday today, so round of applause for Patrick. He did a great job in our discussions every Friday. I mean, a superlative job, and even employed him today on his birthday, which is brutal but truth. That's the price of excellence, Patrick. You have to pay it. You don't have a choice any longer. Pete, can we take a look at, I want to make sure I organize this the right way. I think we should first take a look at the, let's go to tropical tidbits, and just take a look at the week-long forecast over the continental United States and adjacent waters. Because, we'll do it very quickly, because I want to spend some time on Biz 5D. There's a really interesting Pacific storm that has some cool elements in it that I think we'll have some fun looking at. So, and let's just step through this. Let's slide this up so we can see the whole map, because it'll be interesting to see what comes out of here. So let's just click ahead. Here's Helene, and this is now midnight tonight. And because there's a conjunction of that tropical disturbance and the extratropical upper level cutoff that Patrick so expertly showed us, this thing hangs around for a while. But even in that case, watch how fast it goes away. 992 over western Kentucky, 998, 1002, so it's really weakening fast. These are every 6 hours. But the precipitation hangs in there at modest rates. It's not really heavy precipitation in most locations. It'll be enhanced locally in the high terrain. So there'll be some places that continue to have a devastating impact from this thing all weekend long. But it keeps on going. Meanwhile, watch where we are. We're not going to see the southward movement of this anticyclone. Why not? Because the thickness lines are mostly zonally oriented. So this thing's going to slide pretty much in the direction of the thermal wind, but that doesn't mean southeastward. It means more east-southeastward. And here we are by the time we get to midnight Sunday, we still have 570 decameter thickness or higher over us, so relatively mild. I think it'll still be above average for the whole weekend. Probably not very humid, which is different from last weekend. And then more active weather to our west, but let's just keep clicking through quickly, Pete, to just kind of see how long it takes for that to get anywhere near us. Here's the frontal boundary in the thickness field associated with a storm that's going to traverse central Canada early in the week. It won't be until about midday on Tuesday that we really start to feel the cold advection associated with that. So let's see. Yeah, this is just past it. So this is now midday. We're well past it, actually. I guess we're starting around midnight. But that's decent cold air advection. So a relatively mild weekend for us, followed by a cool down for sure, as this substantial baroclinic zone kind of slides southward. By this time, it's all the way down into southern Illinois near St. Louis. So it's going to be considerably colder. Here is fall, and fall occupies North Dakota and parts of Minnesota, and it's on its way towards us. So you can see that. Let me make sure this is turned off, sorry. And let's keep on going, Pete, see what happens. Will it precipitate? Doesn't look like it. All of the frontal precipitation associated with that passage is to our east, even at the beginning of the time, and here we are midday Wednesday. Anticyclone center is over in northeast Missouri, so this is probably going to be about the most pristine fall day we've had in a long time. And then when this thing slides further to the south and east, we get back into the return southwesterly flow to warm us back up. You can see the thickness is starting to creep up late next week, so that's 558. Where are we now in time? Keep going forward. And 564 invades late in the day on Thursday, and then it's on. It gets a little bit warmer. So 570. Finally, by early in the morning on Friday, a week from today, the first semblance of any precipitation in our forecast, tied to a local trophy feature with a baroclinic zone. Undoubtedly, there's some frontogenetic kind of forcing going on there that is helping to make it precipitate. Probably also the air is fairly moist because it's now been a couple of days since the clockwise flow around this feature has dragged Gulf of Mexico type moisture further northward with each passing day. And that's where it meets the baroclinic zone, and so that's where it is thrown into the frontogenetic engine and produces precipitation. So that's roughly what it looks like for us for the coming week. We won't get that spectacular warm-up that we had over that 12-day period in September, but it will flirt with 80 a couple of times, I think. But I think in a much drier environment. We had 68 dew point one day during that stretch, but it was really miserable, 86 over 68. I don't think we're going to see that, but it is going to be warm, unseasonably so, perhaps not so uncomfortably so, because it'll be less humid over the coming week. So that's the one thing I wanted to say about that. Then, I guess this was about the time that the forecast last week suggested tropical storm number 2 emerging in the Gulf of Mexico, which, at least in the current forecast, does not seem to be a substantial threat. And so that's good news for our fellow citizens in the Gulf Coast. It's been probably a really scary couple of days, and it will be devastating several weeks downstream for a lot of those people who are living in that part of the country. They don't seem to have another prospect in the next week. That's changed from last week's 2-week forecast at that time. Now this is a 1-week forecast. So maybe we just page through and see what happens next. I don't think we have any snowfall coming. Patrick showed us the CLIMO for that starts around the last couple of days of October most of the time. Something gets itself organized here on Saturday, but it does not appear to be anything quite like Helene, and that's good news. So there'll be some heavy rain locally in Louisiana, parts of Alabama, it looks like. We can keep going deep. And there goes our precipitation feature sliding through, and I think we're back into northwesterly flow aloft, and I say that because I see the thickness lines oriented in such a way. We can keep clicking. And we can just go all the way through. I don't really have much to say about the forecast. And then yet another storm going through southern Canada, central plains of Canada, spotty precipitation for us early in the following week, and quickly passes by. So I think we stay dry for another extended period here, which maybe gets us off the all-time wettest year record, but that doesn't mean there's a lot of the year left. You know, we're only in the 6th inning, so there's plenty of time to go. And so we'll see what happens next. Okay, so what I'd like to do now is, if we can switch regions, let's go to the North Pacific, which is right here, and we'll go back to the beginning of this. And so this is now at noontime. There's this kind of interesting storm sitting here. Let me get you situated geographically. Here's the Japan, Hokkaido's right here. And so it's at about the latitude of Hokkaido and in the middle of the Bering Sea. So that's a pretty decent storm, 998 millibars. Has an odd look to it though. Not much of a cold front. There is some baroclinicity that's really tight right in here, and that's indicated by the close spacing of the thickness lines. But then it fans out. There's a bit of a pressure trough there, and it fans out again this way with the pressure trough where probably the warm front is right around there. Heavy precipitation forecasted. We're into the 3rd or 4th color bar there. Let's just click a couple of times ahead here and see what happens, and we'll stop at this one. Here's our cyclone. It's deepened a little bit, but the structure, the basic structure has not changed very much. There's an elongated precipitation band in the forecast that stays strongly tied to this baroclinic zone. And the whole structure is kind of stretched in the east-west direction, and there's little tendrils of precipitation in the forecast that hang to the south. It's not really a well-developed cold frontal trough at that point. There's a pretty well-developed warm frontal trough to the east. Let's click ahead a couple more times. This is tomorrow in noontime, and this is kind of tomorrow in the afternoon. Again, extended precipitation band along a strong baroclinic zone, still struggling to form any sort of obvious cold frontal structure, even though the storm is at 989 millibars at its core. Heavy precipitation along the frontal zone that is mostly a warm frontal zone. We can keep clicking ahead, and then keep it a couple more times. This little maximum in the precipitation just continues to exist fairly well downstream of the position of the surface cyclone. We'll see reasons for that in a minute, but that's a strong baroclinic zone, 986 I think that is, or 988. So it's not deepening very much more right now. But the precipitation maintains this orientation with respect to the basic structure of the cyclone. Now it starts to look like a little bit more of a traditional cold frontal structure, especially in the thickness field. It's getting itself organized as the whole baroclinic zone. Remember, it was mostly east-west oriented. It's now been rotated cyclonically. And that probably is a function of some other disturbance in the upper part of the atmosphere coming in and really starting to generate some cyclonic rotation as well as some development. So let's keep clicking ahead a couple more times. 977, well, that's 11 millibars in 6 hours. Let's keep going. 969, it's 8 more. 958, that's 11 more. 949, we can stop right there. That's, I think, 1 day of development, and it's something on the order of 40-ish millibars. This looks totally classical now, doesn't it? It started looking out like this elongated precipitation band that persisted in that structure for a long time, and now we've got this beautiful wrapped up cyclone by the time we get to midnight, 7 p.m. for us on Monday. So this is really an intense disturbance, okay? And so one wonders, what are some of the factors that led to that odd orientation initially, and then the development overall? We'll look at that for a few minutes in Viz 5D. So that's a feature of interest. So let's go to the Viz 5D if we could, Pete. And let's put mean sea level pressure audibly first. Yeah, this is every 4 millibars. Now, don't get fooled by the orientation of this. This is the North Pacific Basin. There's the northern Japanese islands, and so that's the storm of interest. And this is from the GFS 1 degree data, I think, and it's from the 06Z analysis yesterday, or this morning, sorry. And then here's the Canadian-US border, so one imagines that latitude line goes like this across this map, so it's kind of a curved set of latitude lines. So that's the disturbance of interest. Let's put low-level theta E on top of that. And you can see there's a baroclinic zone that stretches from the storm that crashed into the British Columbia coast yesterday, and I've not mentioned it, so I'm bringing this in as extra information. But that was a really beautiful looking cyclone, and it did not last. It's kind of falling apart quickly. 1,000 millibars over the Queen Charlotte Islands. It was much more intense yesterday. Here's the cold front associated with it, and the baroclinic zone extends all the way back almost to Japan in the lower tropospheric theta E. This is at, I forget what height I have that at, 1.4 kilometers. So I'm not even at the ground, I'm at like 850. So that's a really intense theta E gradient, and it goes right into this storm. But it's mostly strong to the east of the cyclone center. You don't see anything back to the south and west. Indicative of the fact that there's not really an obvious cold frontal structure to this nascent little disturbance. Okay? Let's take that off, the theta E off, and I think I add like 500 millibar-ish pressure. Let's see. Yeah, this is at 5.4 kilometers in purple. Sorry, the colors are a little bit clashing. But you can see that broadly, there's a little bit of a trough at 500 millibars, just about exactly in the position of where that little cyclone is. But it's modest. It has very small amount of curvature. There's maybe a local wind speed maxima there, but it's not really the kind of feature that if you took the sea level pressure off, Pete, why don't we do that? Would you expect to see a disturbance of particular interest right there? Probably not, right? That's a weak little feature. You might see something downstream of this over the western Aleutians. That's a pretty sharp upper trough, but this one here is the one with this Canadian cyclone that we haven't described. Okay, so let's put mean sea level pressure back on there. And take the 500 millibar off. And then let's put theta on there. And I gotta remind myself to the level. This is also at about 850 millibars. So this is the lower tropospheric, just dry potential temperature. So broad baroclinic zone, pretty, well, I shouldn't say it's broad, it's pretty intense, but it's especially intense right here, just to the north and east of this weak cyclone center. And then, let's put the two-dimensional frontogenesis on top of there. Look at that. You get this band of really intense horizontal frontogenesis. Two-dimensional just means all we're doing is using the U and the V wind. We're not thinking about the tilting term. There's no omega involved in this calculation. That's a really intense band of horizontal frontogenesis right there. And the consequence of this process that's being testified to by those contours is that the baroclinic zone is being forced to be made stronger locally. The consequence is the production of a thermally direct circulation. So the warm air will rise and the cold air on this side will sink. The warm air rising is certainly adding to some stretching in the column that is going to intensify the circulation around that surface low pressure center. And that column stretching and intensification is downstream or nearly close to the center or downstream of it. And this is something Patrick's seen in his storm that he's looking at, is that another consequence of that thermally direct circulation is the production of precipitation and latent heat release. And that can propagate this disturbance along, maintaining the basic structure because it has a baroclinic zone along which it can find its way effectively. It's like a little breadcrumbs trail. And as long as this process is active and the column's being stretched differentially in these places, it's going to keep on going and doing that. And we'll see that that's the case throughout this. Let's put a vertical cross-section through here, which is a cross-section of theta first, I think. Yeah. And then we'll tilt that up just to see what this thing looks like. So that's a pretty intense horizontal temperature gradient, and it's really locally intense. I mean, if you're out here, you don't have any temperature gradient, you don't have any here, but it's right in there. It's a really narrow zone. For the fun of it, let's put theta E instead of theta. Whoa, look at that. That's like a wall. This is 336 Kelvin, so that's 333, and that's nearly vertically oriented through, I don't know, 5 or 6 kilometers of the atmosphere with an extraordinary temperature gradient right there. Let's put the horizontal frontogenesis on top. And why did I do that, Pete? In my excitement, I didn't think about the colors. Here it is in yellow. So that's a whole other story. Is Andrea here? No, she's not. That's a whole other story. Here's the lower tropospheric frontogenesis, exactly coincident with this intense baroclinic zone. This axis ought to be the dividing line between warm air rising and cold air sinking. Rather than confusing the diagram, I just put omega on. And then we'll take the frontogenesis off. That's all ascending air at 5 centimeters per second and then 5 centimeters per second contours. So in the middle, it's 5, 10, 15, 20, 25, 30, 40 centimeter per second updrafts in the middle and upper troposphere associated with that frontogenesis. So it's really intense and local column stretching. And what that's going to do is take a column of air, stretch it like this, only in that little sector, and that spins up cyclonic vorticity. And that's why the cyclone moves along the baroclinic zone. And so if we go back to our top map view, this is the engine for the propagation, at least, of this disturbance. Let's keep clicking forward a couple of times in time. Wow, that structure stays the same. Here's our cyclone center. It's getting a little more intense. But we'll stop at this one. The frontogenesis axis stays exactly in the same orientation to that position. And it's doing presumably the same things. If we can slide these cross sections to about that spot, Pete. Yeah, and then slide that side a little bit so it's perpendicular to the gradient. Or to the isotopes themselves. This way, we'll go this way. Right there, perfect. And then let's do the same with theta E with theta without showing it. We'll just do it. And we'll show them one at a time. Perfect. Okay, now let's get rid of theta E and omega, and we'll look at the theta this time. What does the structure look like this time in the vertical? So this is now, what is it, 24 hours later? We still have this really locally intense baroclinic zone. I don't know what this is. This is something else. It's also a little baroclinic zone. But this is the really intense one that comes all the way down to the surface. Let's see what it looks like in theta E. Same thing. It's almost the same value. 333 is right there. We have a little bit of convective instability in the boundary layer and a really intense theta E gradient. Look at that. All the way from the ground up to here. It's effectively up to the tropopause. And then omega, or W. Look at that. In continued intense updraft. This thing here is no longer tied to the lower tropospheric frontogenesis. This is something else. In fact, I didn't show you that, did I? The frontogenesis. We didn't move that one yet. We have to do that. Yeah. Let's see if that continues to look the same way and have the same relationship. I suspect that it does. And we'll take theta E off. Not theta E, the vertical motion, just so we can see this better. Yeah, there's the frontogenesis axis. It's exactly the same structure. Really intense axis right there. And then if we put omega on and take that off again. Yeah, so all the assets on the warm side. It's just, it's textbook. And this is happening in the real world, right now, or into the future, I guess, later today. And so this is how, if we go back to the top view, how this cyclone is propagating along and manifesting itself as a continually developing disturbance. Let's go a few more times ahead. Same structure. And these are every 3 hours. Same structure, same structure. We saw this over and over and over again. Same structure, basically. One more time, please. Now it looks like the frontogenesis is getting a little bit more divorced from a deepening low pressure center. This is now 1,004 millibars. Let's keep on going. You can see basically the same structure. Now something's beginning to orient a little bit differently. Especially watch the isotropes in purple. Watch how that whole structure starts to rotate cyclonically in the next few clicks. Right there, it's really starting to begin. So let's take a look. The frontogenesis stays way to the east. It's a consistent feature here. Let's take a look at the potential vorticity. I think you just have to hit OK because I had that set. Yeah, okay, so here we go. And then click it off quickly again, Pete, just so we can remember where we are. Here's the cyclone center. In fact, we can bring mean sea level pressure to the top. That can be helpful. If you click on it again, we can slide it up to 18 or so kilometers. Okay, and then we'll put the PV back on. So here's where our cyclone is. And we've got really deep tropopause depressions further to the north, far to the north. And we have this kind of weaker middle tropospheric one that's right along here. And the shading indicates the pressure at which we're finding the two potential vorticity unit surface. So where it's yellow, it's down at lower elevations, higher pressures. Where it's blue, it's at higher elevations and lower pressures. And right about where there's a little bit of a curve in that surface, that kind of undulating surface, is where our cyclone is. But it really hasn't been generated by anything aloft. It's mostly been by the frontogenesis. Lurking to the north and unknown to this disturbance are these features right here. And if we click forward a few more times, remember we're at the time when things are starting to reorient in the lower troposphere. And let's see if we can figure out a reason why. It looks to me like these disturbances, especially this one, are encroaching upon this little trench in the tropopause. We can keep going, Pete. And especially now, look at how that's getting closer. This lower tropopause height is getting closer to a more obvious curved part of that structure. And you'll see in a couple more of them, clicks ahead, cyclones deepening. Look at what's going to go to town now, because this thing's right on board for really strong development. One more click. That's now 986, 2, wait a minute, Pete. I got to make sure I know what this is. 996, 92, 88, 84, 984. That's well below 94. Let's stop right here. Look at how steep, I'll flip it up in a minute, how steep the tropopause surface is right here upstream of the cyclone center. Let's take sea level pressure off and then just tilt this surface. So it's right here is where the cyclone center is. Look at how steep that tropopause depression is. It beats all of them on the whole regional map. And there's a little bit of a diabatic residue from what's going on in the cloud here. That's a separate issue. Let's do some cross sections here. I think this is at the time that I already got it set. So let's go slide down and do theta prime maybe. Yeah. Somehow I remembered this almost exactly. And let's see. Let's flip that up if we could. And take the PV off. And then slide it so we get the best view of that cross section. I think we're not, yeah, there we go. Okay, so here's the upper tropospheric, here's the tropopause, and then here's this interesting middle tropospheric baroclinic zone, and there's a surface front, which is just, it's like 6 degrees Kelvin across that thing. Let's put the wind speed in the same cross section. So we've got a jet maximum 30, 40, 50, 60, 70 meter per second. This is a superposed jet, because if you're in the 340 to 355 Kelvin layer, you find your jet in this column. If you're in the 315 to 330 layer, you find your jet there. So it's a really intense superposed jet. Extraordinary horizontal shear on the backside, and notice that the negative horizontal shear has to be partitioned outwards because you can't have negative absolute vorticity. There's no limit on how strong the positive vorticity can be. And so that's why the jet core always looks like that.
We're gonna have to wrap up soon. Angel's got a group in here.
All right, I gotta show one more thing. The top map, I think it's at this time. Let's look at the QZ, 500 millibar vorticity, theta prime, is the 700 millibar theta. That color isn't so good. But here's what I want to point out. Here's a vorticity maximum right here. Here's a proxy for the thermal wind in the middle troposphere. It's the gradient of that theta gets really strong, so the thermal wind's intense here and pretty intense up in here. Let's put finally W on top of that. That's the most intense updraft, and that's a function of positive vorticity advection by the thermal wind. Get rid of everything except the omega peak. This will be the last point. And then put mean sea level pressure back on. Son of a gun. It's right near the center of the cycle. So this intense vortex advection downward into the troposphere, and then advection by the thermal wind produces extraordinary vertical motions right where the cyclone's finally going to town and really deepening. So there's a really cool story here about how this all goes together. All right, thanks Pete for the great driving. Patrick, happy birthday and great job on the discussion. We'll see you all next week. I won't be here, so someone else will have to do it. I won't be here. All right, thank you.